And in that 100 grams producing 44 grams or 44 grams produced by 100 grams. So 0.22 grams I got here means how much is calcium carbonate? In this way we can make a simple calculation. That is 0.22 when coming out of the given weight. You must understand the amount of calcium carbonate present in that is corresponding to that. It is only 0.5. So what I calculated is the corresponding weight to the obtained carbon dioxide 0.2 grams of calcium carbonate. And that means in our taken 1 gram limestone, as only 0.422 grams of carbon dioxide came out, it really contained only 0.5 grams of the calcium carbonate. Now you can label that as it is 50% pure, or it has only 50% of that calcium carbonate in that sample. Like this, to analyze the sample, chemical equations we use, and that work is called stoichiometry. Using chemical equations, balanced chemical equations, to calculate the chemical contents of samples is called stoichiometry. So based on chemical equation, the calculations. But here, while doing the calculations, we have options. You can calculate in moles, like 1 mole of calcium carbonate is giving 1 mole this, 1 mole that, says equation. Or when you convert into grams, we got like this. So while doing a calculation, you can have your option. We can do it by grams like this, or if you want to go by moles also, same calculation we can do. Suppose he gave 1 gram of limestone. In that 1 gram of limestone, how much calcium carbonate is present is our question. Let us say it is containing X moles calcium carbonate instead of we say so many grams. We found in gram. Suppose if you want in moles, moles also we can do. What is that? We know 1 mole carbon dioxide corresponds to 1 mole of calcium carbonate, that is well known by the equation. Here he gave the information like this. What is that? 1 gram limestone producing 0.22 grams of carbon dioxide. But I wish to go by moles count, and you are good at finding moles from weight also. Suppose here 0.22 grams he said, but I express in moles, because when weight is given, you can express it in moles also. It is so many moles carbon dioxide, is right, because weight by molecular weight is moles number. So 1 mole carbon dioxide corresponds to 1 mole calcium carbonate, known from equation, but here 0.22 by 44 moles, that corresponds to how much moles. In this way you get moles number first. How many moles you got from this? You can calculate. 0.22 by 44 moles corresponds to how many moles? Same number of moles, that is 0.22 by 44 only. And after getting that moles number, then if you want, we can convert into weight. Therefore, weight of calcium carbonate equal to the number of moles of calcium carbonate is also so much only, and moles when known you can convert into gram, and we get once again same 0.5 gram. So while doing that expression calculation, while using the relation according to chemical equation, you can go by moles and then come to weight, or you can directly convert into weight. All these are our options. But while doing these calculations, you must remember one important thing. It is not just to do that calculation and go, because stoichiometry or the relations between the compounds interacting is very important in so many other reactions, other chapters. So you must accustom to do it in more systematic way, so that we can apply for other chapters more comfortably. In that, more appropriate way of handling this stoichiometry is by moles always. So as much as possible, your work should go with moles. Wherever convenient, weights can be used. So many ways you can do, but prefer to go as much as possible by moles, so that in so many further calculations, our calculations becomes easier. And also the concept of equivalent weight can be used well. In fact, concept of equivalent weight looks more comfortable also. But only problem with equivalent weight concept is you must be more cautious in deciding that equivalent weight first. After getting equivalent weight correctly, no problem. We can easily analyze that and do. I will give an example. In that, whether equivalent weights consideration is good or moles is good, you decide. For example, just now I gave one other example also. Potassium permanganate with oxalic acid reacting, and in that the balanced equation I am putting straight away. In sulfuric acid medium, it reacts to form potassium sulfate, manganese. It is already we use in balancing practice also, and carbon dioxide, water, like that. In that, okay, they are reacting like this in 2:5 mole ratio. The details I am not telling because you know how to balance all these equations. 10 carbon dioxide, 3 H2SO4, 8 H2O, like that. It is a balanced equation. So when there is analysis needed based on this reaction, it is mainly between these substances which are interacting, one oxidizing agent, other reducing agent. And on this equation, when you want to go for some calculation, depending on the information available, you choose to take moles, weights, equivalents, etc. But always prefer to do by moles as first preference, and be ready to use equivalents also. Conveniently we do, because this is a method in which it is your choice to handle that. But prefer always moles and equivalents so that calculation can be made very easily. Suppose I said potassium permanganate solution is used, like some 0.02 molar potassium permanganate solution is brought, and I ask how much of this potassium permanganate solution can exactly react with a certain say 2 moles of oxalic acid. Here I brought a potassium permanganate solution and I brought 0.2 moles of oxalic acid, and a question can be put here: how many liters or how many ml or how much volume of this potassium permanganate solution can exactly react with so much of oxalic acid? A question I gave. Here you have options, either to go by moles or to go by equivalents. Moles means the ratio we find when there is a balanced chemical equation. We understand that 2 moles potassium permanganate react exactly with 5 moles of oxalic acid. Equation says that is applying moles. Otherwise, we have a way to tell in terms of equivalence. What is that? According to law of chemical equivalence, the law of chemical equivalence says every 2 substances when they react always in 1:1:1 ratio of their equivalents only. One equivalent of this substance reacts with one equivalent only of the other substance, always. Whereas moles wise a certain ratio, you must understand by looking at the chemical equation. So when you want to apply moles, depending on this mole ratio, and when you want to apply equivalents, you know it is always in 1:1 ratio only. But problem is with equivalents, you must be cautious and be sure that you know the right equivalent weight and then go ahead. Now 0.2 moles of oxalic acid I took. This 0.2 moles oxalic acid, I once again write, it is oxalic acid, as you see in the equation, this is oxalic acid. Now 0.02 molar solution taken, and it must react with this. And what you know about equation, they always react in 2:5 ratio, 2:5 mole ratio. Here for this oxalic acid in the question, it is also given that 0.2 moles are taken. Here 0.2 moles taken, here 0.02 molar solution taken, and we want to find how much of this is being reacting, say V ml I wrote. We want to find how many ml of the solution going to react with this. Then simply do like this. Because it is 0.2 moles given there, and because here molarity given and you want to find volume. What is the relation between volume, molarity and moles? Simply like this. Molarity is nothing but moles liters ratio. Moles of solute to liters of solutions ratio. That's why here molarity when given, you can find moles number, millimoles number, whatever you want. So here you can do like this. Because it is for oxalic acid moles number given, for other one I am expressing moles number like this. 0.02 is molarity given, and V is the volume of solution you want to find in ml, and to 10 power minus 3, so that now it becomes liters. You understand the expression clearly?